All right, everybody, let's look at the solutions for homework 4. Remembering that this module is mostly about just visualizing data, which is why there's quite a few less options here. It's just more about making things pretty, making things easier to understand, making sure we're using the right scales. We're not deceiving people by showing the sort of data that we're showing. So let's just jump right into it here. Let me start a new Excel book. And let's go look at start a blank one, okay. So let's go look at the link here provided, Florida Department of Health. We're gonna be looking at the data for those years by county. Okay, we're looking for obesity rates. We want Escambia, Santa Rosa, and the whole state. Okay, obesity. All right, where's obesity? Probably here, overweight and obesity. And then it talked about obese specifically, and I want to see both county and state. So we're gonna have to pull these separately, it looks like. Maybe, let's go see. So let's look at the county. It said we wanted Escambia, which is here. And as luck would have it, these are the exact years that we wanted. So let's see how easy this is to export. All right, let me get all the counties first before we go crazy here. So there's Escambia. What was the other one? I think Santa Rosa was one. Santa Rosa. I wonder if we can just copy and paste this in here. Oof. Enable editing. Okay. Okay, so we got Escambia, Santa Rosa, and who else did we need? Let's go back and look. Escambia, Santa Rosa, and then just the state. Okay. So let's go back here and look. Let's go back here, view the state. Okay, so here's the numbers for the state. So these years are slightly different. We'll just copy them all and figure it out. Okay, so I'm gonna go to the book I opened and make it a little bit prettier here. Okay, so we wanted Escambia, Santa Rosa, Florida. Let's go look at the years. I forget. 2, 7, 10, 13, 16. Okay. These are obesity rates. So let's go look at Escambia. That's this one. So I'm just going to do some manual typing here just to save some time. 25, 28.7. 29.7. Okay, so we got Escambia. Let's go look at Santa Rosa. .3. Yeah, that's a big jump. 29.8. 25.6. 31.6. It's kind of all over the place. Did I get that right? Yep. Okay, now the state's gonna be a little bit different because its years are different. So for 2002, we got 22.3. And we went 2007, 24.1, 2010, 27.2, and 2013, 26.4, and 2016, 27.4. Okay, I was going to read through the problem just to make sure I didn't miss anything. Went to the website, got those years, county level, single graph. Okay, we'll do that. Obesity for those 2 counties in the state. Okay, they're just talking about a paragraph. Okay. So now we can just make a graph. Let's go see. Insert a graph here. Pretty straightforward. Oh, that's weird. I'm going to redo this. I don't like that. See if I can change the selected data. All right, I'm just going to redo that. I don't like that it included the obesity rates in there. Let's go to insert. Let's just do a bar. There we go. Okay. So we could follow what the state is doing and just add a trend line if we want. Don't get anything too fancy. You probably want, yeah, a linear regression's fine. So we'll add that. Okay, so here's what we are showing. So it looks like Escambia is quite a bit higher, except for this last year, than the state or Santa Rosa. And for some reason, it looks like Santa Rosa has a pretty big jump. And then it's asking, what is it? 1 paragraph description of your findings. The years are not equally separated. That's true. So I'll just be looking for whatever sort of suggestion you want to put in there, describing your data. Pretty much anything would be fine, as long as it's not too crazy. Okay, let's go look at numbered. So I already did this homework a little bit earlier, just before I did this video, just to make sure I wasn't out in left field. So I want to go look at that really quick, just to make sure we got all the right data. And I posted it over here under modules, under homework 4. I'm starting this review thing. I'm going to post a video here, but here's the solution I worked through earlier. So I just want to go look and see if I got the same numbers and compare it. Loading number 1. So something similar. I just want to look at the numbers between the two. I put them backwards. So on the left here I got Florida and Escambia, Santa Rosa. Here I got Escambia, Santa Rosa, Florida. So I put them in different order. I'm just going to double check that the numbers are right. That first one's right, and check the last one. 27.4, 28, 31. Yep, so the numbers are right. And the graphs are looking extremely similar. And again, the peaks look a little bit different here because of the order of which I have the counties, but it is the same stuff. Because you can see I have all of Florida here versus Escambia first, and that's why the peaks look a little bit different. They're in different orders. Okay, so it looks good. So we're going to hang on to that sheet in the background just for reference in the future. We can rename this to Q1. And again, don't forget to go add your paragraph in there. Let's go look here at number 2, question 2. Going straight to the homework description so I don't mess it up. Okay, question 2. Go to the charts database on the data query on the left-hand side. Let's close out these ones we already did. Okay, number 2. Go to the charts database on the data queries tab on the left-hand side of the website. So that's here, data queries. Let's see. Okay, so from 2008 to 2017, create a graph that tracks teenage birth rates for these counties and then birth counts for these counties. Which one's more informative and why? Okay. So let's go here. Oh, so we got it separated already. Counts and rates. That's easy. So we're going to go to birth counts first because it's listed first. And it wanted underage for just a couple of counties. Okay. What was it, 2008 to 18, I think. Let's go look for these 10 years. Get rid of 2019 because I didn't want that. Come on. Just thinking. Hopefully I didn't break it. Come on. That's so funny. When I was doing this earlier, it didn't take any time at all. There we go. Okay, and then we want to make sure we're just getting the teenage people. So we'll go look at the mother's age. And we'll just select 0 to 14 and 15 to 19. There's a little bit of overlap because 19 is adult, so we just kind of want up till 18, but there's not a way to get that level of granularity. So I'm just going to select these 2 boxes anyways, knowing we're getting a little bit extra. Well, I guess it just says teenage, right? It doesn't say underage. Let me go back and check. It just says teenage, so that's fine. 19's teen. Okay, and if we really wanted to get super specific, I think we could, yeah, county. So let's go filter by county. Unselect them all. We wanted Escambia, Santa Rosa, and I think Orange. So there's Orange and then Santa Rosa. Santa Rosa. Hit OK. Now we should get just the data we want. There we go. Looks pretty good. We'll just export that out to Excel. Open this up. I'm just going to go copy this into the other book that we're using. Nope. This one. Okay, so this one is the birth count. We also need the birth rates. So let's close this. Let's go look for birth rates. Birth rates. Oof, I was hoping it was going to keep all my same filters, but it did not. I don't think. No. Yep, birth rates. Okay, let's go set those same counties and select Escambia, Orange, Santa Rosa. Click. Okay. And then we want 2008 to 18. Get rid of 2019, and then we wanted just teens. So the mother's age. And again, 0 through 14. And then 15 through 19. There we go, so it's right there. Okay, we're gonna export this one. So these ones are the rates. Did I do it? Oh, yep, okay. Yes. Copy. Let's go to hours. Okay, so we have birth rate, birth count for just our counties and just those years for only teens. And you can tell here it's saying mother's age, making sure it's all the same. Okay. And then what's the question asking us to do? Now that we've got our data, create a graph for rate and a similar graph for counts. Which one's more informative? Okay. That should be pretty easy. I don't want to include the totals. Those aren't going to be helpful for a graph. Well, I guess instead of deleting it, I'll just move it out of the way so we have it later. We don't want the totals. That's going to throw everything off. Oops. Okay. So now we just need to create a graph. Insert, let's just do a bar chart again. Okay, so there's this guy. He's birth count. And we'll do likewise another one. Let's select this data again. Insert bar chart. This would be birth rate. Did it tell us to do the whole state? No, just those counties. Okay. So we don't want to have this total either. I'm just going to get rid of the total here. We just want those 3 counties. Do the same thing here, get rid of the total. Okay, so then the question is, which one of these graphs is telling us the most accurate? That's what it says, what's the most accurate graph? Which graph do you think is more informative? Okay. Hopefully you're going to come to the same answer, because the answer I'm looking for, it's really what's the difference between count and rate. Count is semi-useless on its own. It's only good for comparing one county to the same county year to year. Because for example, what is it, like Miami-Dade County is going to have millions and millions of people, whereas like Orange County or Santa Rosa County, it looks like, is going to have tens of thousands of people. And so you're going to expect the counts of people in like Miami to be way higher than they are going to be in Santa Rosa, just because there's more people living there. So the raw counts don't mean anything. They're pretty unusable. And you can even see right here, right? Orange County must have a lot more people because they're having like 8 or 10 times the number of births as Santa Rosa. So the raw counts are not very helpful unless you're just comparing the same county, like Santa Rosa year to year or Orange County year to year. That's helpful. That's fine. But what's a better graph is a rate. And the reason rates are better is because we put them into comparable denominators here. So this is per 1,000 people. And that's why rates are important. So we can say, even though Miami has, let's say 10 million people, I have no idea what it is. And then we can say Santa Rosa has 500,000. We convert that into the same denominator of 1,000 people. So now we can compare apples to apples, and we got a per capita unit here. That's what these rates are showing us. And so, for example, it's saying for every, so looking at 2018 here, for about every 4 people, we have a birth. And over here in Escambia, we have a birth from a teen about every 7,000 people. And these are very useful and informative things because we've normalized the numbers to be per capita. So it takes into account how big that county is. And we divide it by 1,000 to get the normalized numbers. The rates is what we're calling it here. So this is by far the rates, or the per capita, is going to be the only useful graph here. So hopefully you came to a similar conclusion, apples to apples here. Okay. Number 3, I remember, is going to be a big one. It took me a while to do that. Hang on. Let's go back and look at, first we're going to close this. Let's go look at the homework I did earlier. I've done this twice today. The first one was preparing for this video. There we go. Oh, I just didn't remove the totals. Let me do that. Well, I'm not going to mess with it. You can see I have 4 here because I left in the totals from all of Florida. And that even makes this point even more likely, right? Because you can see, you can't even see these numbers here on just the raw counts by county when you're talking about the whole state. But by using the per capita, it's normalized those numbers, and you can see all of them, and you can see some of them are even higher than Florida. I think this makes the point even better by leaving those Florida totals in there. Because you can see, what's this blue one? You can see Escambia has a higher birth rate than the whole state on average for all of these years. But you cannot tell that by looking here, right? It looks like it's a tiny little sliver. And in fact, it looks like Orange County has more birth rates than Escambia. When in fact, once you normalize those to per capita, Orange County is less than Escambia. Escambia is the highest between these 3 for most of those years. It looks like Santa Rosa caught up here in the last year. Anyways, I hope that helps clarify why rates are important and why that graph matters. Okay, let's go look at the last one. I remember this took a while. I might copy and paste some data to save us some time. But let's get started just to see. So we go to the population characteristics length in the health indicators tab. What does that mean? Let me close this. Population characteristics, health indicators. Okay, here's health indicators. Oh, there we go. Population characteristics. That makes sense. And then what are we doing? Population data by year, by county. Population data. You get the data by year, by county. Okay. Population data. That's what you said. By county. Yeah, so we have 4 choices here. Looks like this is probably the closest one to what's being asked. Yeah, that's easy. So we want all the counties 2014 to 2018. Let's go filter out by year. Yeah, 2014, 15, 18. That works out pretty well. Huh. That was like the default or something. Make sure I'm reading this right. Okay, so let's just go download this. That looks like the data we want. Let's go export that to Excel. Opening. Just gonna copy it all. Let's go to our book. Oh, not that one. This one. Create a new tab. Rename it to Q3 for question 3. Oops, sorry, question 3. Let's paste in our data. Let's make these columns big enough. Just making these big enough to see all the data. Okay, so we got the data. We don't need this website anymore. Annual growth rate of each year. Okay, so to get a growth rate, it's a two-step thing then. Okay, so we're going from 2014 to 15. I'm going to insert a blank cell, or row, sorry. Insert a blank row. Insert a blank row, and then insert a blank row. Okay, so I'm going to do 2014 to 2015, just the count difference. This will be 2015 to 2016 count difference. 2016 to 2017. I think we're calling it raw count, so we'll stick with that. And then 2017 to 2018. 17 to 18 raw count. Okay, so this will be easy. We're just going to do, helps write characters, equals most recent year minus the year before. And then we'll just run that down for all the counties. Okay, likewise, we'll do 16 to 15. Run that down. This is just telling us the raw difference. And then 2017 to 16. And again, these numbers are useful for county level. They're not going to be useful to compare to one another. So I'm going to do another calculation here after this one. Okay. I'm just going to color these so they're easier to stick out. I don't know, something like that. Okay. Okay, so these are the raw counts, and these are interesting per county, right? So we can say Bay County grew by about 2,700 that year, grew 2,600, 2,300, 3,200, right? We can see a bit of a trend in the county. It went down, and then it went a pretty big spike back up. That's interesting for the county. It's not going to be interesting to compare it, right? We can't compare like Bradford County numbers to Broward County numbers because this is obviously a much, much bigger county. So what we need to do is we get the rate. That's what we just talked about earlier. We need to get what's the rate change. I'm going to insert another set of column to do that. Just give it a rate. Okay, so to get the rate for this specific example, we're going to say how many people were added or subtracted from how many we started with. And then we're going to turn this into a percentage. That should be a times, not a... and I need to give these some precision. This isn't keeping track of decimal points. So I'm going to go format these cells, turn them into numbers, tell them to keep track of a good 5 levels of significance. There we go. And let's drag this all the way down. Okay, we're going to do the same thing. We had that change. We had this start. And then we just need to turn that into percentage. Drag it down. Okay. So again, we got that. Times 100. We're almost there. Hang with me. Drag it down. I guess you could fast forward the video if you wanted, but we're almost there. Okay, last one. Ish. That's the rate change, divide by the rate start. Times 100 to percentage it, drag it down. Okay. Okay, so this whole chapter, this whole module, I should say, was about visualizing data, right? You could find a way to graph this. You know, I haven't graded anybody's homework, so you can. I'll be interested to see what you guys did here. But what I like to do for just tables and numbers like this, let's see. What column is it? Oh, I was on it already, sorry. So there's a lot of this conditional formatting stuff. I like to do data bars for something like this. Yeah, so we just want positive and negative. Okay, so we can see here pretty easily visualized who the biggest winners and losers are, right? So red means you lost population, blue means you gained it, and you can see sort of how far over it goes. If we make these bars bigger, it will make those a little bit easier to read. But we get the general idea. So you can quickly look and see where like this one looks really big, right? This bar goes way over there, and that's a 4.4 rate. And we got a similar minus 4.2 rate. So you can pretty easily jump in. But the question I think it was asking us here is, what is the third fastest growing county in the state? Let's see. I'm just going to sum these up here. This is going to be the net. What's the column? So net rate change. Not just net change, just net rate change. Because again, we don't want to compare county numbers, the raw counts. We only want to compare rates. So if we can sum this up over these years, we can see that year, that year, that year, and that year. Sum them all up. So all the big ones and little ones will sum up. Let's drag it down to do it for everybody. And again, I'm just going to use this visualization again here. But this time we can do the, I guess top 10. The question was asking the top 3. There we go. So these are the top 3. I don't like the color. Because red seems like it's negative, right? Let's do the top 3. But instead of red, let's do green. Yeah, green's positive. Okay. See, so these guys had 5.3, 3.3, 3.35, which added up to 14.7. These guys had 19. These guys had 12. So these are the top 3. The question is asking, I think it said, what was the third? What was the third fastest growing county in the state? If I were to say guess, I would say this one. Looks like Walton was the third biggest. I would be curious to see if there's negatives over all those years. Can we do that again? So we did have some negatives. Looks like Taylor went down. Oof. Lafayette went down pretty big. So we have a few more. Gulf and Hardy, they went down. But it's these 3. You see they're green. Yeah, and again, so Walton. Okay, so that's how I would answer that question. I think he's asking other things in here. What does he say? He's asking about the mean of the 4. Did I miss something? Let's see. Select population data. Get data in the population by year. You can tell I inherited this class. I didn't write these questions or write the material. And there's no answer key from the person I inherited this from, so I have to go through and do all the homework myself, which is what you're watching here. Um, oh yeah, it is accurate. The average growth rate. Well, to do an average, we're going to need all of it. And it wants the average growth rate. Oh, from 2014 to 2018. Oh. Okay. Let's do that really quick. Hang on, that's annoying me. Get rid of that. So you're saying from the whole 14 to 18, not intermediate years. What's the average? Okay. And I'm going to stick to the rates, not the population. Get up there. Oh, I don't know if that's... Nope. That's not going to answer the question he's asking. I'm going to need to do a different one. I'm going to need to do a rate from 2014 to 2018 without the intermediate years. Okay. So first we got to do the count difference. And there's more than one way to do what I'm doing. So I apologize if you did it differently, as long as we come out to similar conclusions. So we're going to do 2018 minus 2014. He's saying just to do the whole things, I think. So we're going for averages here. Let's see. Okay, and then let's do the rate. Let's turn that into a percentile times 100. Make sure this is set up for number. Okay. Okay, so this is the average from the, oops, one more. From the 14th to the 18th. Let's just apply the same rules here as we did earlier. Let's do, sure, we can add data bars, but let's also add, oh, the top. Yeah, I want to see the top 3. And we'll turn those green again. All right, let's see if the averages give us anything different than we did year by year. Oh yeah, it's the same. So the numbers are different, right? Because we have 20.8 versus 19.4, 15.6 versus 14.7, 13, and 12. They're very similar though. So this is the average, right? So all of the average from 14 to 18, and these are just more granular year by year by year. And we actually come out with the same. I mean, again, the numbers are going to be different, but we get the same 3 in green, right? I'm just double checking. 1, 2, 3. Yeah, those are the same. Let's make sure our third, I think we came up with Walton was our bottom. So 13, 15, 20, yeah. So Walton is still going to be the same, and it's actually very similar. 12.4 versus 13.06. Yeah, pretty similar. Is this what he was asking for? Why is the growth rate usually in... Okay, so why is it different? Because we're jumping from A to D, right? So we have, right, this is year A, B, C, and D, the differences. It's kind of like calculus. When you're trying to find the area under a curve, you can get, depending on how big your bars are, you're going to get different numbers on how granular you can be with the numbers to get the area under a curve. And so we're just jumping from 14 to 18, whereas we're doing the differences here year by year. But we do come up with very similar things. So anyways, put that into your answers and submit them. And if you're anywhere near this general thing. And again, we're trying to look to visualize. That was this whole module. So try to find a way to visualize this data if you haven't already. Hopefully this makes sense. If you did graphs, that's fine. I'll be curious to see what they look like. And good luck on the homework.